All right, here's a nice question where they ask you to find the zeros of this polynomial. I don't know if they ask you to graph it, but you can find the zeros. So I need to factor this function here. Now it has an x to the fourth, but I think that I could factor if I put in brackets here. I'm going to take the x to the fourth, and I'm going to split it into x squared and x squared. Okay, if I multiply those together, that'll give me x to the fourth. Then I find two numbers that multiply to 10 and add to negative 10, or add to 9 and add to negative 10. So I think it'll be 9 and 1, and both will be negative. Okay, now if you want to check that, you can FOIL it. So this times this, x to the fourth, this times this, negative 9x squared, this times this, negative 1x squared, and if you add those together, you get negative 10, and then negative 1 times negative 9 is a positive 9, and so you do come up with the original function. So, let me erase this stuff. So when I factor it, I get this. But those don't give me x-intercepts because they're still quadratic factors. That's an x to the squared. But that's a difference of squares, so I can factor that to x minus 1 and x plus 1. Then I can do the same thing with this one. It'll be x minus 3 and x plus 3. Okay, so that's my function factored. Now if I want to find the zeros, so I set this f of x to 0 equals all of these, and then I set each one of those to 0. So this one will give me x equals 1, this will be x equals minus 1, x equals 3, x equals minus 3. So those are all the x-intercepts. So now to graph that, I just have to find those points. So there's 1 and minus 1, 3 and minus 3, and I know since it's a coordinate graph that it starts high and ends high, and it has 3 bumps in it, 1, 2, 3, and it has a y-intercept of 9 right there. So this is what the graph is going to look like. And I just did it on decimals, but it looks pretty good. Hopefully that helps you with that question.